Master Experiments here. So today I'm going to show you how to synthesize peracetic acid. Peracetic acid is what you get when you combine vinegar and hydrogen peroxide. Vinegar being acetic acid and hydrogen peroxide being a oxidizing agent. Peracetic acid can dissolve pretty much any metal you throw at it. It can dissolve copper. It can even dissolve copper, which is the metal that only like nitric acid can usually dissolve. So anyway, I'm gonna make it. All you do is you mix vinegar and hydrogen peroxide. I usually mix them in like a 50-50-ish ratio. So yeah, I'm gonna show you how I do that. Before I begin, I'm gonna warn you, peracetic acid isn't very dangerous since it's not a strong acid, but it smells very strongly of vinegar, so if you don't really like that smell, I'd suggest doing this outside or with a cap on it. And another thing, do not flush it down drains because it can dissolve metals, so yeah. And most pipes are metal, so it can be seriously corrosive to drain pipes. So those are the two things that I'm warning you before you create it. This is my 5% household vinegar, and this is my 3% hydrogen peroxide. I'm adding an excess of vinegar, since you usually add an excess of hydrogen peroxide. There we go. There are a couple things you should be careful with this compound. The main thing being that the fumes that it produces can be kind of dangerous to your eyes. So yeah. I'm going to use my waste copper right here. This is just copper from my old electroplating experiments. I'm going to take the mixture and wash most of the copper out of here too. This mainly because I'm kind of sick of waiting for my copper sulfate production rig to keep going, and I want a copper electroplating solution ASAP. So yeah. This will take about 8 hours before it dissolves all of the copper and stuff. And then you just keep adding more copper or whatever metal you want to dissolve to the solution until you get it. The thing is that this solution, it's pretty awesome because it can dissolve pretty much any metal. The only metal acetate salt that is insoluble, I believe, is silver. So you can dissolve any metal outside of silver with this solution. I'm using this waste copper because it's from like old electrodes that I dissolved with my copper sulfate electroplating experiments, and it would really just get thrown away if I didn't do this with it. So yeah, I'm gonna put my hydrogen peroxide back in my bathroom, and actually this stuff formed, I think it's kind of interesting that this stuff formed copper hydroxide on the bottom because it was wet and I let it oxidize. So yeah, I'm gonna put a top on this container so that it doesn't let out those nasty peracetic acid fumes. And yeah, I'm just gonna wait. That copper waste was in a very fine powder since I filtered it out of my copper sulfate solution. So the reaction is going extremely fast, as you can see. It is going to dissolve all of that copper junk. And it's also going to dissolve all of this junk as well. Then afterwards, I'll test the solution by smelling it. If it still smells like acetic acid, I'll continue adding copper until it doesn't, after all this copper dissolves. And then I'll just filter it at the end to remove any copper waste or impurities. And then I can start electroplating with it. The solution won't be very concentrated since the hydrogen peroxide and the vinegar aren't very concentrated. But I've got this copper sulfate solution that I made via electroplating. I mean, via the method that I showed in my electrolysis rig V4 video. And I'm going to use this copper sulfate. As this stuff evaporates, as I use it for electroplating, I'm going to add the copper sulfate to it. Had very many problems with bubbling before with this reaction, but now that I'm using like copper waste, which is like very fine pieces of wire and like powder and stuff, instead of pennies, there is some bubbling issues. I had to transfer more of the solution into here. So yeah. Long story short, when my magnesium sulfate from my old electrolysis rig finishes filtering, it's got a lot of magnesium hydroxide contamination. So I'm filtering it to be nice and clear. I'm storing it in there. Once this finishes filtering, I'm going to filter out all the copper gunk from this copper acetate solution. And it doesn't really smell very badly of vinegar. About 16 hours, there's a very slight hint. So by the time this is done filtering, this should be ready to filter. But what have we learned today? First things first, we have learned that sometimes it's not necessarily the strength of an acid that makes it a good acid. Sometimes oxidizing power really comes in handy, especially when it comes to dissolving metals that have a higher that are higher on the reactivity, lower on the reactivity table than hydrogen, because even the strongest acids can't dissolve metals like that. So yeah, sometimes it's oxidizing power that can really make or break an acid, you see. So yeah, but in my next video, I'm going to be producing a Birkeland-ide for making nitric acid. And nitric acid is an acid as strong as hydrochloric acid, which is stomach acid, a very strong acid, and it's a stronger oxidizing agent, or equal in oxidizing power to peracetic acid, so it's the best of both worlds. So that video is hopefully going to be coming up soon. I capped it, and this is like just a waste. But yeah, hope you enjoyed, and see you in the next video.